Hello, this is Alex from CloudRF here with the first of a three-part series into HF, or the art of HF, because it is an art form. It's very different to terrestrial planning. The most important principle is frequency selection. It doesn't matter if you've got high power, if you've got a great mast, if you haven't got the right frequency for the right time of day, you will not be making that link. So the link we're going to use for this tutorial is a relatively short link in the world of HF. We're going from Penzance at the bottom of the UK up to the top of the UK at John O'Groats, so it's a 1,000-kilometre link. The reason we're doing 1,000 kilometres is significant because we want to go further than the NVIS limit. So NVIS, this is near vertical incidence skywave, is one bounce up, one bounce down. This is 500 kilometres, so that would get you up to about Manchester here in the UK. We need to do HF planning, and so we're going to go all the way up to 1,000 kilometres, and we're going to try this link on relatively low power, 10 watts. So quite ambitious. So to do this, we need to pick a good frequency for the time of the day and the time of the year. To do that, use the HF model here, HF Skywave, and the path tool, and select your destination, so John O'Groats up here. This will perform a frequency analysis for the time of year and the time that you've selected and the height of your mast. For starters, I would recommend just putting it above head height, so just put it at 4 meters. We will adjust the mast and the antenna later on in the antennas video, which is a separate chapter. So we have a chart here. Let's blow this chart up and click PNG and talk about the chart. So the chart is showing us frequencies over times of day, and there's several different frequencies across the HF spectrum from 2 megahertz up to 20 megahertz. So we have a nice selection to play with. The power for this is 30 watts, but please ignore power for now. You can add on more power later once you've picked the right settings. And the month is April. This is significant because if we repeat this exercise in a different month, we will get a different chart because the weather, the seasons are different, and they do affect the ionosphere. So what we're looking at here is which frequencies are best. So a higher value, SNR on the left, is best. And we can see that there's good day frequencies from 7 AM to 7 PM, and there's good night frequencies. So I want a day frequency, so that will be the red one here, which is 11 megahertz, or a frequency close to 11 megahertz will be good. And for night, there's a hand over here. You can see 11 megahertz collapses at sunset, and this guy, 5 megahertz, the orange line, comes racing up very steeply. So as the sun goes down, 5 megahertz opens up, and this becomes a very good night frequency. So a frequency close to 5, lower down the spectrum, is my night frequency, and 11 is my day. So I've noted those two frequencies, and I'm happy that I have an improved chance of success now of making this link. So let's go ahead and run an area calculation with this model to see what our frequency looks like. So let's start with our day frequency, 11 megahertz. Let's drop the power to 10 megahertz because HF is all about frequency selection and antennas. Power, that's just a bonus. You should bring your power in later once you've established a good antenna on a good frequency. So we're 10 watts of power, 2,000 kilometer radius, so we can see beyond our objective, so we can see where we're going. This uses the VOACAP engine under the hood, and we can see we have a heat map now out to 2,000 kilometer radius. The parameters that we used for the antenna, well, that was a dipole. We'll cover that in detail in the antennas video. But from this heat map, we can see that we've scored an immediate goal because we have a good signal. You can see a band of good signal across our objective at the top of Scotland here. That is a S3 on the HF scale. So the HF colour keys on the side here from neg 73. That's why hams say 7 threes, and down to neg 121 because it's very narrow band, so we can go that low. So that's an S1, and we've got S2 or 3 up here at the top of Scotland, so that would just be workable. However, time is critical. That's workable in April at 12 o'clock UTC. What happens if we play with the time? What happens if we try this same frequency at 8 o'clock at night, so 2000 UTC? Let's click the button and have a look. Interesting. A big hole has appeared. This is a skip zone. So the HF signal is going up, it's hitting the ionosphere, which has changed because of the time of day, and it's coming down on the Earth beyond 500 kilometers. Remember, we talked about 500 kilometers being the NVIS limit. So now we're doing proper HF skywave, and we're using the ionosphere beyond the 1 hop distance. It's much better down in Spain, so Spain's got a good signal, so you could talk well to Spain on this frequency at this time, but it's barely workable up in Scotland there. And if you had any noise, if you put on any interference in the reliability option here, we would probably lose the ability to talk to Scotland. So what happens if we stay on this frequency, if we don't move to our night frequency? Well, 9 o'clock at night, gets dark, starts to get dark in April, and the hole has got bigger, and interestingly, this line has appeared on our coverage coming from the east. So that's not a mistake, that's not a glitch in the system. The Earth is rotating, and this is sunset. So this is darkness about to cover us now, and you can actually see that in the coverage. And you can see the different coverage. Again, we're good down in southern Spain, but we're unworkable at the top of Scotland. So we need to switch to that night frequency. So let's go and do that now. So we're going to switch frequencies and go to that 5 megahertz frequency. Still only 10 watts of power. Wow, what a difference. Incredibly strong signal. There'll be a lot of people chattering on this at night because it's a good frequency to use. And a night and day difference between the two frequencies at the same time. So that just goes to show the difference between picking the right frequency for the time of day. So that's frequency selection in a nutshell. In the next video, we will delve into antenna design and how to make a long-range link with low power using a carefully constructed antenna.